Welcome to part 1 of Competency 14. For this competency, a teacher understands the relationship among probability theory, sampling, and statistical inference, and how statistical inference is used in making and evaluating predictions. In this video, we will work with binomial distribution. Number 1. An ordinary coin is tossed 15 times. Assume that the probability of landing on heads or tails is 1/2. What is the probability of getting heads exactly 6 times? We deal with this by using binomial distribution. Given is the expression. Now, please be aware that this expression will not be given to you on your formula sheets. You're going to have to know this if it's asked of you. So note what we have here. We have the combination of the number of trials and how many of those are a success, which is n. And then you have the probability of a successful trial, and then you multiply that to the probability of all the unsuccessful trials. Okay, so let's put this first one in our calculator. Okay, so we need to figure out what is the number of trials. So let's see here. Our capital N would be the number of successes. We want 6. Our probability is 1/2. And our number of trials is 15. Okay, so we type in 15, prob, we need number 2. Now we need 6 out of those 15, so you need 6. Now we're going to multiply each of these elements together. So you push multiplication, and I'm going to go ahead and type in 1/2. You could put 0.5, I suppose. So here's my fraction, 1/2. Now we have to use caret up because that would be to the 6th power. Okay, and then I arrow over times. Now this would be 1 minus the probability of a success. Well, that's 1/2 in this case also. So we type in our fraction, 1/2. Now, what is our exponent? Let's go caret up and let's think about this. That would be the number of trials minus 6. Well, don't try to do that math in your head. Just type in 16 minus the 6. It's more accurate. Okay, the less you do while you're stressed out during a test, less brain power you use, the more success you're going to have in this situation. So let's push enter. Okay, and that looks like option C. Perfect. Okay, the trick is to remember the expression for binomial distribution. Okay, and it's not tough if you just remember, okay, I'm using a combination of how many successes out of trials times the success of those, the successful desired outcomes would be 6 times the undesired. So if you can remember this, you'll be fine. All right, so let's look at number 2. A bag of 10 marbles has 4 red marbles with the remaining blue. If you choose 3 marbles at random, one at a time, what is the probability that you will select exactly 2 red marbles? Okay, be careful with this. We're using 10 and 4 for our probability. But what are we using for our number of trials and our successes? So make sure you think this out. Let's see. It asks us for how many times for 2 red. So that's 2. Capital N is 2. Now what about our probabilities? Well, that would be 4 out of the 10. Okay. And number of trials, that's 3. Okay, so let's put that in the calculator. We have 3 prob. We want number 2 because that's our combinations. And then we want to test 2 out of 3. Okay, now times. Okay, what is our probability? Well, I'm going to go ahead and put in a fraction. And I'm going to say 4 out of 10. I'm not going to do the math in my head. It isn't worth it. Okay, now how many times are we looking at? Well, we have a target of 2. Okay, that's our desired. So I would just say squared. You don't have to use a caret up for that, of course. And then times. Now, what are we not? What is not a favorable outcome or not a success? Well, I'm going to go ahead and use parentheses. Okay, 1 minus fraction 4 over the 10. Close my, oops, let me delete that, go over. Now close your parentheses. And that would be n minus the number of trials and lowercase n minus uppercase. So that'd be 3 minus 2. That's just 1. So I would leave that as is. Now let's push enter. Okay, here's the discrepancy, but it really isn't. All we have to do is just push our toggle button and we have the option B. Okay. All right, let's try number 3. Number 3, an ordinary die is rolled 7 times. Okay, so that's our n, our small n. What is the probability that a number greater than 4 will show exactly once? Okay, so we know the capital N is going to be 1, and our probability of an ordinary die, well, we have a total of 6, but it's asking us numbers greater than 4. Well, that's 5 and 6, so that's 2 out of 6. Okay, and we can go ahead and say that that's 1/3. Okay, let's put this in the calculator. Okay, so we need 7 prob, and then go to number 2. But we only want one instance, okay? Now we need to multiply that times the successes, okay, to the exponent of 1 in this case, okay? So that would be, set up your fraction, that's 1/3, 1/3, but we don't need to put it to the power of an exponent because it's simply 1. So now we need to multiply that times our non-success. Okay, well, what would our non-success be? Well, that would be, well, 1/3's what we want as our success. So 2/3 would be our non-success. So that would be 2 over 3. Now this would be 6 minus, it would be 6 because 7 minus 1. So that's our exponent, 7 minus 1. Okay, now let's push enter. Okay, let's see what we have. That would be option A. Perfect. And as you can see, there is also notation that would be appropriate with this. The probability of x equals 1, where x is our number of successes. Okay. All right, let's look at number 4. The probability of a salesperson making a sale with any one customer is 1/3. If the salesperson averages 8 contacts per day, what is the probability that the salesperson will make 4 sales a day? Okay, so you have n equals 8. Okay, that's our number of trials, our lowercase n. They gave us the probability, and the number of trials is going to be, not number of trials, number of successes, sorry about that, is simply 4. Okay, well, that's actually kind of convenient when we put it in the calculator. So we need to put 8 first, then push oops, let's go back to that. Okay, we'll clear everything out. Let's try it again. 8 prob, number 2. Now we want 4 out of those 8. So we want 4 times, and our probability is 1/3 again. So 1/3. Okay. Now we need to put that to the power of 4. That's how many successes. A sale is a success. Now arrow over and multiply that to the non-success. So that would be 2/3 again. So 2/3. Arrow over, what would that probability be then? Well, 8 minus 4 is 4. So carry it up and 4 again. That's pretty convenient. Well, actually, this question would be, you would be less apt to make a mistake, actually, I think. Okay, so let's push enter, and there you go. Looks like option C is correct with rounding. Of course, we'd have to round. Okay. All right, number 5. During the prior season, a basketball player makes 3/8 of the baskets attempted. If the basketball player attempts to make a basket 20 times in the next game, what is the probability that the player will make 11 baskets? Okay, well, let's set this up. Looks like our number of trials is 20. All right, so let me push clear. We have 20 prob, then 2, and we want 11 out of those 20 times. Now, what is our percent, our probability rather of success? That's 3/8. So 3 out of 8. Now, what number is that raised to be raised to 11? Because 11 is what we're looking for. That's our success. So carry it up, 11, and arrow over times. Now let's set up our new fraction. Obviously, our non-success would be 5 out of the 8. And then what would we put that up to? Well, let's not do that in our head. Carry it up. 20 minus 11. Okay. Which is 9. But I'm not going to do that in my head. I want to make sure I'm accurate. So let's push enter. Okay, let's see what we have. With some rounding, looks like option A is what we need. Okay. All right, this is the last question in this video. Thank you for watching, subscribing, liking, and sharing. It is absolutely fabulous that people are beginning to watch more and saying kind things. Happy testing, everyone.